Lesson 5 is the second of 3 lessons on ratio, and at the beginning of the lesson you had your rules and definitions that you should have gone over by now. And there's a fraction decimal percent chart there, and that's something you'll want to memorize if you don't already have those things memorized. This will be very helpful to you in mathematics and when you apply math in science, just being able to quickly move back and forth from fractions to decimals. One confusing thing is that a fraction, like a half, when you change that to decimal form, it doesn't look like a fraction anymore. And so you might be confused into thinking, well, I'm not working with fractions anymore. Well, yes, you are. It's just a different way of describing a fraction. And then when you're working with percent as well, these are all equal to each other. 50% means 50 per 100. Or baseball. A batter has a good batting average if for every 10 times he goes up to the plate, he gets a hit 3 of those 10 times. So 3 out of 10 times. And so we might say his batting average is 0.3, and usually it's written out to 3 decimal places. So it would be said that his batting average is 300. So when somebody says, oh, that person's batting average is 300, what they really mean is 0.300, or 30 out of every 100 times, 3 out of every 10, 30 out of every 100 times, or 30% of the time they go up to the plate to bat, they get a hit. So it's not just knowing, oh, well, that's a decent batting average, 0.300 or 300. What does that mean, though? It means 3 out of every 10 times, or 30 out of every 100, or 300 out of every 1,000 times they go up to the plate. On average, they get a hit that many times. So remember, math is a language, and so understanding what the language is saying is very important. So with languages, sometimes we have different ways of saying the same thing. So for example, you may start the day with chores to complete, and your mother says to you, please finish all your chores before you play. Now, I'm sure you would never do this, but there's other children out there who might whine and complain about their chores, end up not doing them, and then the mother gets exasperated and she says, do your chores now. So different ways of saying the same thing. So don't think of this fraction decimal percent relationship here as anything more than just different ways of saying the same thing. Memorize those different fraction decimal percent relationships in the table at the beginning of the lesson in the workbook. Let's look at an example now. Fill in the empty cells of that table there. Round missing decimal and percent values to 2 decimal places. And you may use a calculator for this. So let's start with row 1 there. And you have a 0.75 in the decimal place. And so maybe you remember that 1/4 equals 0.25, or you look in your table and you recognize 1/4 equals 0.25 equals 25%. So from that, it follows that 3/4 would be 75%. And so 0.75 is 75% is 3/4. Now for the next row, also you can look at patterns from your table. Notice that 12.5 times 5 is 62.5. So 1/8 equals 0.125 equals 12.5. 5/8, that equals 0.625 equals 62.5%. There's other ways to think about this too. Like you look at the 62.5% and you should know, well, that's saying 62.5 hundredths, which means over 100, or move the decimal over 2 places and you get 0.625. Now row 3 there, we're looking at 1/7, and that's not in the table. So what do? Well, this is where you can get your calculator out. And 1/7, do that, just do 1 and then hit the division symbol on your calculator, 7. You should get a decimal result for that, 0.142857. Probably have more decimal places than that even. I'll just go ahead and stop there. But that's the decimal value. Let's just round that to 2 decimal places. That's what the instructions say to do. 0.14 would be rounded to 2 decimal places. And That's 14 hundredths. So the percent would just be 14.2857 or 0.29. We'll round that to 2 decimal places as well. 14.29%. And so this one here, we could actually just round that to 0.63 to show it as 2 decimal places. So use the table in your workbook, use your calculator, use both of those back and forth to get the right values when you do problems like this in your problem set. These are all just different ways of saying the same thing. Let's move on to the second part of this lesson, and multiplication and division of fractions. Let's start there, and then we'll do decimals. So multiplication of fractions, to multiply them, multiply the numerators together and multiply the denominators. That's a little bit different than addition and subtraction, like you learned in Lesson 4. And again, like Lesson 4, if multiplication and division of fractions and decimals is review to you, then you can go ahead and go on to your problem set. But if you need to practice, just take a look at that. 1 times 1 is 1 over 2 times 2 is 4. So half of a half. So thinking of it that way, thinking of it as half of a half, that is sometimes helpful instead of thinking of it just as half times half, because times just is a shorthand for the times symbol. But what are you doing? Well, you're taking half of a half. That's what's going on. And it might help to just show a diagram again. And so on the left there, we have half shaded. Now, what if you shade in or just think about half of that half piece? Well, that would just be this right here. That would be 1/4, right? I mean, if somebody asked you, how much pizza do you want? You wouldn't say, well, I want half of a half. I mean, you could say that, but you're probably not going to say that. You're going to say it in a more simplified way. You're going to say, I would like 1/4 of the pizza. Let's do some examples. Example 5.2, multiply that, reduce if necessary. So 1/4 times 1/3. So, I mean, we could just draw a circle here and split it into thirds as accurately as we can, and think of 1/3. Now, let's think about 1/4 of that 1/3 piece. I mean, that's not going to be very much of it, right? Because we need to split it up into 4 pieces itself. So that right there would be 1/4 of 1/3. That's a pretty small amount. So 1 times 1 is 1. 4 times 3 is 12. It's 1/12 is what 1/4 of 1/3 is. So our diagram helps us make sense of that answer and just kind of check our work and think, well, yeah, 1/12 does make sense, a small result there. So on B, let's go ahead and do that. 3/5 times 5/8. Now, here's something important to recognize, is that in multiplication, order doesn't matter, right? 3 times 5 is the same thing as 5 times 3. So as long as you're multiplying these fractions together, you can move things around. So let's just move the 5 and the 3 and say 5 times 3 instead of 3 times 5. So do you notice now we have a 5 over a 5, and that's just equal to 1? So we're really doing 1 times 3/8 is 3/8. So we can cancel those similar factors out like that if you see those in the numerator and denominator. Do you see something like that in C that you could cancel? You don't have to rearrange it first, just cancel it. So look, the 7 over 7. And so we can greatly simplify that problem, and it's just going to be 4/8. And 4/8 is 1/2, right? So that reduces down to 1/2. So let's say if we didn't recognize the 7 over 7 there, we would have said 7 times 4 is 28, over 8 times 7 is 56, and then we have this really big ratio there, and maybe you would recognize right away that that's half, but maybe you didn't, and you're like, okay, well, I got to cut this in half. I got 14 over 28, 7 over 14, okay, that's a half. Either way, it would have been a lot faster if you would have recognized you had a 7 as a factor in the numerator and denominator, so those would cancel because that equals 1. So that word of, that's helpful when we're thinking of multiplying fractions. Half of a half. So it's helpful when we have a word problem involving fraction multiplication. We can use a memory aid, f times a equals b, and we can pronounce that f of a equals b, where f stands for fraction. Fraction of something equals the result. So look at example 5.3. 1/4 of 60 equals what number? Well, we can see it's a fraction word problem, so let's just write down our little formula there, our mnemonic or memory aid. F times a equals b. F of a equals b. Do you see there's 3 parts to that? And in these kind of word problems like this, they'll give you 2 of the 3 parts. Otherwise, you can't solve the problem, right? You need 2 of the 3 parts to just have one unknown value left. So 1/4 of 60, that's like saying 1/4 times 60. So f is 1/4. Dot for times, 60 is the a, equals, and we'll just say wn for what number there for the b. 1/4 of 60 equals what number? So 1/4 times 60, that's like saying 1/4 times 60 over 1, right? And so you can just say that that equals 60 over 4. So you have a division problem now, 60 divided by 4. Well, 4 goes into 60 exactly 15 times. So if you needed to do long division on that, you can. But that's what that would equal, is 15. Notice what we did there, that we wrote that whole number part as a fraction. And so we were able to multiply numerators, multiply denominators, and then we had one fraction left, which we divided to get the result. Now, it doesn't have to just be f times a equals b. It could be d for decimal, right? Because decimal is just another way to write a fraction. D times a, or d of a, is b. So look at example 5.4. 0.2 of 35 equals what number? So here again we have d. For decimal, we have that decimal instead of a fraction. D times a equals b. Well, 0.2 times 35 equals, I'll just say wn for what number? Writing a descriptive variable, it's called wn, which stands for something. It stands for what number. So now I just need to do 35 times 0.2. And so I'll just do that over to the side here, and I'll do 35 times 2. And remember, that's how you do multiplication with decimals. You just do the multiplication first, and then you add the decimals back in. So that would equal 70. And so I want to add the decimal point back in, 1 decimal. So that is equal to 7.0. And then we could also do percentage times a equals b. We could have p over 100. Because usually they'll give you the percentage, like they'll say 20%, but that's the same thing as 20 over 100, right? So we can say whatever the percentage they gave you over 100 times a equals b. So like this one, it'd be 20% of 35 equals what number? So 20 over 100 times 35 equals what number? Well, how can we simplify this? Instead of 20 over 100, we could say 2 over 10, 0.2, right? That's 0.2. We could write it as a decimal, 0.2 times 35. And we already know what that is. It's 35 times 2 is 70. Add the decimal back in. That's equal to 7.0. So there's our answer. 20% of 35. It's the same thing as asking 0.2 of 35. It just looks different. So these are actually the same problem, right? We got the same answer, 7.0 for both of them. If you didn't realize these were both going to give the same answer, then that's something just to keep in mind, that maybe you're not catching on that percent decimal fraction. There are different ways of saying the same thing. Those are good things to recognize. Okay, let's move on to division of fractions now. And the best way to divide fractions is to multiply the dividend by the reciprocal of the divisor. So we turn the division problem into a multiplication problem. So for example, we can solve 2 divided by half. we can say 2 divided by half is the same thing as 2 over 1 divided by 1/2, which is the same thing as 2 over 1 times 2 over 1. So this part right here, we flipped it, made it 2 over 1, and we changed the division to a multiplication. And we get 4 over 1 equals 4. Remember this right here. A simple way to think about dividing by fractions is to invert and multiply. So we're saying, how many halves can I split 2 wholes into? Well, just count them right here in this example here. There's 1, 2, 3, 4 of them, right? There's 4 halves. I could split 2 whole pieces into 4 halves. So we can see how that works. We can see how 2 divided by half is the same thing as 2 times 2. So by looking at that example, it helps us know that there's a reason for this invert and multiply step here. So let's do some division now. 4 divided by half, let's do A. So what we're really doing is 4 times 2 over 1, or just 4 times 2, right? So that would be 8. And hopefully that makes sense. We just did 2 divided by half. How many halves can you break 2 into? Well, 4 halves. This is saying how many halves can you break 4 into? Well, 8 halves is the result. Okay, and then B, 1/3 divided by 1/8 is 1/3 times 8 over 1. And so that's equal to 8/3. How many 1/8 can I divide 1/3 into? Well, you can divide it into 8/3, or 2 2/3 1/8 pieces, which sounds really weird, but that's what it does. And then C, 3/5 divided by 3/10, well, that's going to be 3 over 5 times 10 over 3. And so here, think about what we learned earlier about multiplying fractions. We can cancel, even though they're not right on top of each other. We know that equals 1 right there. And then 10 over 5, hopefully you know that that's equal to 2 in your head. 10/5 is the same thing as 2. So the answer there is 2. Okay, and let's do one more example here. And in lesson 2, we reviewed long division with a remainder. Now here, let's use decimals instead of remainders. So let's do a couple of examples. A, 169 divided by 4, and round the answers to 2 decimal places. So we'll do 4 into 169. And so we'll say 4 goes into 1 0 times. It goes into 16 4 times. And so we subtract, and 16 minus 16 is 0. Bring down the 9. 4 goes into 9 2 times, and so that would be 8. So subtract, and so we'll have a 1. Now it's just 169, but what do we do here? We put a place value or decimal point there, and decimal point up here too. Line them up. And now let's add a placeholder 0 and bring that 0 down. 4 goes into 10 2 times, and so we'll have an 8 here. Subtract, and we get 2. Another placeholder 0, and I'll bring down the 0, and 4 goes into 20 exactly 5 times. So we'll just go ahead and stop there. 42.25. That's the answer there for 169 divided by 4. Look at B, 65 divided by 6. So we're going to say 6 goes into 65. And we have 6 goes into 6 one time. So we'll subtract there. Get a 0, bring down the 5. 6 goes into 5 0 times. And so we'll have a 0 there. Subtract, and we get 5. And now a placeholder, but we need to add a decimal point here and in the quotient. Add a placeholder 0, bring that down. 6 goes into 50 8 times. And we have 48 there. Subtract, and we'd get 2. Bring down another placeholder 0, and we'll have 6 goes into 23 times, and that would be an 18. Subtract, get 2. We need another placeholder. 6 goes into that 23 times, and that's 18. Do you see this is just going to keep repeating now? So it's just going to be 3 continuously, so we can just write that answer as 10.83 with a bar over it. Or since we've been asked to write to 2 decimal places, we could just say 10.83 without the bar. Okay, so on those division problems, just keep up with that decimal place. A lot of times you have to add that on there, as well as placeholder zeros to help you do the division properly. Okay, well that's all for lesson 5.